Hi, this is the second lecture that I'm going to talk about factoring polynomials. Uh, if you remember, we started talking about factoring polynomials by introducing some methods. The first method is that if we could factor out a common factor from all the terms, we pull that one out. And if you remember, the second method was I was discussing about how to factor polynomials using the identities that we have learned so far. We talked about the quadratic identity, we talked about conjugate on the identity, and we talked about the identity giving the sum of cubes, a cubed plus b cubed, and the difference of cubes, a cubed minus b cubed. Today, I want to talk about the next identity, which is sometimes useful to factorizing the polynomials. Okay, the identity that I want to discuss today. So that is this identity we had before. If we have x plus a times x plus b, this can be written as x squared. So I have two binomials. I want to multiply them. There is a common term there. So the answer is the common term to the two, and then plus the sum of two terms multiplied by the common term. And then finally, we have a times b, which is the product of two uncommon terms. Okay, and I think it's a very good to start with examples. So example, so we want to factor the following polynomials. So number one, x squared plus 5x plus 6. Okay, so what you see here on the right hand side, if you can detect this pattern where I have three terms and then one of them is a complete square, it might be the case that I can use this rule to actually factorize my polynomial. Okay, so if you compare this one with this expression, x squared is exactly x squared, but instead of a plus b times x, I have 5x, and instead of ab, I have simply 6. Okay, can you guess two numbers a and b such that the sum becomes 5 and the product becomes 6? If the answer is if you can guess, then it's very simple, yeah? So if you want to follow this pattern, this is going to play the role of the common term. So I will open two brackets, put the common term in both of them, and try to guess. I want two numbers whose sum s, let me call s for sum, is positive 5, and the product is positive 6. It's not that hard to guess these two numbers, yes? Two numbers are positive 2 and positive 3. Positive 2 plus positive 3 is 5, so the sum is indeed 5. And if I multiply 2 by 3, it becomes positive 6. Yes, so those numbers that I am looking for is positive 2 and positive 3. So I put one of them in the first pair of brackets, and in the second one in the second pair of brackets. So that is a factorization of my polynomial. If you multiply these two brackets, x squared, the sum of these two numbers multiplied by the common factor, and then you have the product of these two terms, yes? On the other hand, this expression is equal to this expression, and this expression is in the product form. So it means that I have done the factorization. Okay, so of course you see that this method is a little bit of based on guess, yes? I was able to guess those two numbers. Of course, it might happen that these numbers are big, so I cannot guess. I will gradually talk about that. And then, but most of the time you face these kinds of problems. So it's very important to know this method for at least a small number. So let us practice this a little bit together. Okay, so let me just write some of them for you. So x number 2, let us play around with these signs first. So I have x squared, then minus 5x minus 6. Yes. So you see that I have a trinomial, a polynomial containing exactly 3 terms. One of them is complete square. So I can probably compare this with the right hand side of this identity. Yes. Okay. So if this is going to be the case, that this problem is going to be solved by this formula, then I can write 2x's here in front. And I ask myself, I need two numbers whose sum is equal to -5 and product is -6. Yes? So what are those two numbers? It's not hard to guess, yes? So one of those numbers is -6, the other one is +1, yes? So I put +1 here, for example, and I put -6 here. Okay, so let us try to guess. Let us try to check it again. +1 added to -6 becomes -5. +1 multiplied by -6 becomes -6. So those numbers are indeed correct. So that's a valid factorization. Yes. So number 3. I have x squared plus 5x minus 6 this time. Yes. Of course, you immediately see that I have a trinomial. One of them is complete square. So it means that might be I will be able to use that identity to solve the problem. So what can I do then? I would put the common factor here, the common term here, and then I would ask myself, I need two numbers whose sum is +5 and the product is -6. Yes? So can you guess those two numbers? Okay, this time one of them is +6 and the other one is -1. Yes? I don't think that this is hard for you to guess. Let us check. -1 plus 6 becomes +5. -1 times 6 becomes -6. So that's also a valid factorization. So let us go to the next one. Of course, by practice, you will learn how to do these things quickly. But of course, if the numbers are actually big, even myself cannot do them, then I will teach you a systematic way. But most of the time, you will be able to guess those two numbers, especially in practical exam questions or other questions that you will face. Okay, so number 4. So number 4, I would write it in this form: x squared minus x minus 6. Yes, again, you can compare this one with the general form. You have a trinomial. The first one is complete square. So if this is going to be solved using that, I will write x and x in two pair of brackets, and I will try to guess the numbers. I need two numbers whose sum is -1 here, because minus x means -1x, and then p is -6. So I need to guess two numbers whose product is -6 and the sum is -1. And I think it is not that hard to guess that one of them is -3 and the other one is +2. -3 plus 2 becomes -1. -3 times 2 becomes -6. Yes. Okay, number 5, for example. I have x squared minus 2x minus 35. Yes. Again, the same scenario. So I have x here and I have x there. I need to ask myself, I need two numbers whose sum is -2, whose product is -35. So for example, the numbers whose product is 35 is either 1 and 35 or 7 and 5. But 7 and 5 have somehow a relation to 2, yes? The difference between 7 and 5 is 2. The only thing that remains is to adjust the signs, yes? So might be you could guess that one of them is 5 and the other one is 7, because 5 times 7 somehow will give me 35, but you know that the product is supposed to be negative, so one of them should be positive and the other one should be negative. And then because the sum is a negative number, actually the bigger one should contain the negative sign. Yes, so this becomes positive, this becomes negative. Let us check it again. Positive 5 plus negative 7 is indeed negative 2. Positive 5 times negative 7 is negative 35. Yes. Okay, another one. So I have x squared minus 7x minus 60. Yes. So I want to factorize this. I intentionally made the numbers a little bit bigger. I just told you that if you cannot guess those numbers, you need to be a little bit patient. I will go back to it and then try to tell you how to systematically find those two numbers, okay? But let us improve our skills in guessing those numbers. So here, I put x here, and I put x there, and then I need two numbers whose sum is negative 7, and the product is negative 60. Okay, so probably it's a good point to start from here. So if you want to write 60 as a product, you might write 1 times 60. There is no relation with the negative with 7. If I add 1 and 60 in any type of any possible signs, it will not give me negative 7 for sure. 230 the same, 320 the same, and then I have 4 and 15, for example, the same, 12 and 5. 12 and 5, by the way, is a good idea, yes, because the difference between 12 and 5 is actually 7. So it might be a good guess here. So let me write 5 and 12 here, and then I have to adjust the signs. Again, the product is negative, one of them has to be positive, the other one has to be negative, and because the sum is negative, then I need to give the negative sign to the bigger one, yes, and then positive sign here. So it might be a little bit harder, but I think if you are a little bit friend with numbers, especially the numbers of these orders, then it's not hard to calculate this. Okay, let me give you another example. So number 7, what happens if I want to factorize this? 2x squared plus 20x, and then I have plus 48. Okay. Okay, this immediately, of course, does not work. Yes, why? Because I have a trinomial, I have a polynomial consisting exactly 3 terms. But the point is that this term, which appears here, is no longer a complete square. Yes, but you see that here on the right-hand side, I start with a complete square. Okay, but then if you remember from my previous lecture, the first method that I talked about was pulling out an expression or a common factor from all the terms if possible. And at the end of that method, I told you that this method will have the priority over to all other methods that will come next. Yes, so this is one of those cases. You see, before start thinking about what to do, you immediately realize that 2 is a common factor between all these terms. So the first thing that we have to do is to pull out this common factor and then think, what should I do next? Okay, so I take the 2 out. From this one, x squared is left. From the next one, 10x, and the other one, 24. Now, what is left in these pair of brackets? Of course, I told you that this is in product form, but when we say factorize, you need to continue as much as possible. Yes, so it might happen that I can still go further. And in this case, indeed, I can, yes? Yes, let us see. This is very similar to what we had before. So I would write that if this is going to be solved using this identity, then I put x here and x here, and I ask myself, I need two numbers whose sum is positive 10 and its product is 24. Yes, the product is 24. So product of 24 is 124, no relations with 10. I don't know, 2 times 12, 3 times 8, and 4 times 6. 4 times 6, the sum becomes exactly positive 2. So I put a 4 here and a 6 here, and then the product is positive, the sum is also positive, so both of them has to be positive. Of course, you can recheck this again. 4 and 6 added to the sum is 10 and the product is 24. So that is the complete factorization of this polynomial. Okay, now let me go to the next. So it's very wet. Let me keep the identity here. Okay. The next one, let me write this one for you. So number 8, it's 4x squared, and then I have 4x minus 15. Yes. Okay. Look here. Still, I have a trinomial. I have 3 terms. I have a complete square, of course. 4x squared is itself a complete square. And I cannot factor 4 out from all the terms. So I need to deal with 4 here. I cannot throw it away. This is not something similar to this that I can pull out the 4 and then solve the rest. Okay, but this is not a big problem here because 4x squared is itself a complete square. So you need to interpret this in this form. So 2x to the 2. So it means that if you compare this one with the right-hand side of this identity, what is going to be common term? If this is going to be solved using this identity, the common term should be 2x. Yes, so if the common term is 2x, so x will be 2x. So instead of 4x, you can imagine the common term is 2x, but you need 4x, so you multiply it by 2x. And then I write minus 15. Yes, and then it means that if this is going to be solved using that identity, the 2x, which is here and here, will play the role of the common term. So I will open 2 pairs of brackets, put 2x in each one of them, and then I ask myself, I need 2 numbers whose sum is not 4, is 2, and the product is negative 15. Yes? So what are those 2 numbers? So the numbers should be 3 and 5. You can immediately guess. So I put 3 and 5 here, and I have to adjust the signs. So the product is negative, so one of them is negative, one of them is positive, but because the sum is positive, the bigger one is positive, and this one is negative. So I hope that you understand. Let me try to expand it if you don't understand. You see, I have a common term here. So this tells you that if you want to expand, if you want to multiply 2 binomials having a common term, sharing a term in they have a term so in common, so you need to write the common term to the 2, and then you need to add these 2 numbers, which becomes positive 2, and multiply it by the common term, and then you multiply them, which becomes minus 15. And if you compare this one with this one, that they are exactly the same. So sometimes you need to be careful. The point is to factorize using this identity, but the common term is not simply x. The common term is something else. You need to decide it. So I will give you some exercise from here for this type of problems. So let me solve one more of this type at least. So number 9, I have 25x squared minus 5x, and then I have minus 42. Okay, so if you see, again, I have a trinomial. One of them is complete square, even though that complete square is not x squared. It is something else squared. What is that? Instead of 25x squared, I can write 5x to the 2. As soon as you write 5x to the 2, it means that your intention is to solve the problem, to factorize the polynomial using this identity, but taking 5x to play the role of this common term x. Yes, if that's the case, so it means that what you have to have on the middle term is again your common term. Okay, so you need 5x as your common term. What you have here, you have negative your common term. So negative your common term in principle is negative 1 times x, yes? And then it's minus 42. So then I open two pairs of brackets, put 5x as my common term in these two brackets, and I ask myself, can I find two numbers whose sum is negative 1 and its product is negative 42? Yes, it's not that hard. The numbers that the product becomes negative 42 and has a relation when we add them with minus 1 are 7 and 6, yes? So I put 7 or 6 in one of them and 7 in the other one. And then because the product is negative and the sum is negative, the bigger one should be negative, the smaller one should be positive. And if, of course, you can always double check. If I give you this and I ask you to expand, you immediately realize that 5x is your common term. So according to this identity, you would write the common term to the two, which becomes 25x squared. And then you will add these two numbers, which gives you minus 1. And then minus 1 multiplied by the common term will give you minus 5x. And then finally, you multiply these two terms, which gives you negative 42. Yes. Okay. Now we can expand the idea a little bit. So let me clean here. Okay. So for example, number 10, I have x squared minus 3 to the 2, and then I have minus 7 x squared minus 3 plus 6. Yes. I want to factorize this polynomial. Of course, this polynomial is not a trinomial in the exact sense of the word, because if I raise it to power 2, it gives me 3 terms, and then I will have 2 terms here. I simplify them, I will have more than 3 terms, of course. But it is written in the form of a trinomial. Yes, I can consider this as one term, consider this as the second one, and that the third one. And the good point is that one of them is a complete square. So I get suspicious that this might work. This identity might work for this case. So it will help me to factorize the polynomial. But if this is going to be the case, what is going to play the role of the common term? Yes, x squared minus 3 in its own will play the role of the common term. Yes, so I would write, I will open two brackets, two pairs of brackets, and then I put x squared minus 3, which I want to play the role of the common term in these two brackets separately. And then what do? I will ask myself, I need two numbers whose sum is negative 7 and the product is positive 6. Okay, so what are those numbers? So the numbers that will give me the product 6, this is 1 and 6, but 1 and 6 is actually good, yes, because 1 and 6 added will give me 7, but I need to adjust the signs, yes. So I would write 1 and 6 here, but I need to adjust the signs. What are the signs? The product is supposed to be positive, so either both of them are positive or both of them are negative. But the sum is supposed to be negative, so it means that they have to be both negative numbers. So I would write this and that. Of course, I told you, if you remember, when we factorize, we have to simplify, yes? Nobody leaves x squared minus 3 minus 1 as it is in this form. Minus 3 minus 1 has a better name, that's minus 4. So I will continue to simplify. So it becomes x squared minus 4, and then I have x squared minus 9. Of course, this is already in the factorized form, but it is not complete. I hope that you remember and you can immediately realize these factors. are actually revealing conjugate pattern, both here and there. So I have to continue and factorize them. So what would be the answer? X squared minus 4 using the conjugate identity can be written as x minus 2, x plus 2. And x squared minus 9 can be written x minus 3 and x plus 3. So this is the full factorization of that expression. Yes? So this example is a good example that you need to broaden your perspective to be able to detect the patterns and use those patterns to simplify. So let me give you one example here and then go to the next part. So number 11, what happens if I want to factorize this? Okay, this one is also a little bit tricky. It involves more than one variable x and y. Okay, again, I have a trinomial. I have a polynomial consisting of 3 terms, and one of them is complete square. Okay, so I might get suspicious that it might be helpful if I use this identity there. But as before, what is the complete square? This is the complete square for 2x. Okay, so let us write it in that one. If this is going to be solved using this problem, I need to arrange this a little bit, okay? Reorder it, rearrange it. So I will write 2x to the 2. And then by writing this, I already mean that I am going to let 2x play the role of the common term. If that is the case, so I need to write this in a way that 2x is apparently clear in this writing. Yes, it is 8xy, so I would write it in this form. I would write 2x because I need it as my common term, and then I try to adjust what is left. So I want to go back to 8xy, so it means that I need to multiply by 4y. Yes. And then for the last one, I cannot do anything. Okay? But can you guess the idea? If I want to use again this, so then 2x will play the role of the common term. So I open 2 pairs of brackets, put 2x here, 2x there. But this time you see that what is sitting here is not a number, is itself a monomial, an expression involving variables. And this one is also the same. But this is not actually an obstacle. You can just ask yourself, can I guess 2 expressions such that the sum is 4y and the product is negative 21y squared? If you can guess those 2 expressions, then you put one of them here, the other one there, and then you are done. And I don't think it's very hard, yes? So what are those 2 expressions? So minus 21 can be written as 3 times 7 with, of course, the different signs, but I want to keep the sum to be positive 4. So I don't think it's hard to guess that one of them is positive 7y and the other one is negative 3y. Let us check again. This 2x will play the role of the common term. So according to that identity, the common term will be raised to power 2. So if I raise the common term to the power of 2, it gives me 4x squared. And then I need to add these 2, which are not common, and then multiply the sum by the common term. When I add them together, it becomes 7y minus 3y, it becomes 4y. And if I multiply 4y by the common term 2x, it becomes 8xy. And if I multiply these 2 uncommon terms, it becomes exactly 7y times minus 3y becomes negative 20y squared. That is also possible. Okay? Okay, now let us go and change the type of examples. In these cases, I had a complete square, but sometimes I do not have any complete squares involved. But still, if I be a little bit smarter, I can use the same identity to factorize my polynomial. So I want to talk about that one right now. Okay, so let me clean this. So let me give an example again. So factorize. Okay, so one of them, let me start with this one. 2x squared plus 7x plus 3. Yes. Okay, so if I want to factorize this, first let us check everything. This is a trinomial. Yes. Okay. I don't have any complete squares. Can I factor 2 out from all the terms? Yes, you can, but you will get 7 over 2 and 3 over 2. Okay. So probably it's not that a good idea, because then you need to think about fractions adding to 7 over 2 and then multiplied by 3 over 2. It might be possible, by the way. Let me go back to it after I just gave you the method that I want to describe right now. Okay, so I will give you two methods for solving these type of problems, that you have a trinomial, but you don't have a complete square in the beginning. Okay, so let me solve it with two methods. So method number one. In method number one, I would write this expression. Okay, okay, for making this complete square, I need a factor of 2, because if this, instead of 2x squared, if I had 4x squared, then that was a complete square. But of course, this is not 4x squared. What I can do, I can multiply everything by 2 and then divide by divide by 2 again. Or I can write it as 1 over 2. Okay, I am dividing this by 2. So to compensate that, I have to multiply by 2 this expression. Okay, so when I multiply this by 2, it becomes 4x squared. But 4x squared is now a complete. So by the way, if you don't mind, let me just do it in 2 steps. Okay, so I multiply everything by 2 and I multiply by 1/2 to compensate for that. So what happens? It becomes 4x squared, and then it becomes 14x, and then it becomes 6. Yes. So I hope that you understand that this equality is indeed valid. Yes. If you multiply this 1/2 inside, what will happen? The first one becomes 2x squared, the second one becomes 7x, the last one becomes 3. So everything is in order. But then this part of the problem is exactly that type of problems that we talked before. So I don't have them on the board, but more or less you know what to do. You have a trinomial here now, and then you have a complete square. Okay, what you need to do, you need to give the role of the common term to 2x. Yes, by writing how? You would write it as 1 over 2, and then you would write 2x to the power of 2. Okay, but because 2x is going to play the role of the common term, it should be manifest here. You should write it in a way that is completely obvious there. So instead of 14x, I write 2x, but to go back to 14, I need a factor of 7. 7 times 2x is exactly 14, and then I will have 6 there. Okay, now hopefully you know that. I put this equality, so I need to copy paste this 1/2. But then I know that I want to give the role of the common term to 2x, so I open 2 pairs of brackets, put 2x here, 2x there, and then I will ask myself, can I find two numbers whose sum is positive 7, as product is positive 6? The answer is yes. One of them is 1, the other one is 6. So I put 1 here, and then I put 6 here. Yes? And of course, if you see, this is in factorized form. But of course, this 1 over 2, usually I told you that by default, when we want to factorize, we factorize on the domain of integers. So can I get rid of 1 over 2? The answer is yes. By the way, this is not fully factorized yet, because this part on its own can be factorized more. If I pull 2 out, it becomes x plus 3. Yes. And then point is that I have 1 number, 2 number, 2 numbers, 3 numbers, and 4 numbers. I want to multiply them. I can just multiply them in any combination that I want. So this 1/2 and this 2 will be canceled. So what is left for me is 2x plus 1, x plus 2. So this is very easy again. So if you don't have a complete square, if you do not start with a complete square, so you need to multiply it by a number, making it complete a square. What is that number? That number is exactly this number sitting here. You multiply everything by that number, but you are not allowed to just multiply by a number, changing your expression. But if you write equality and multiply by 2 and divide by 2, you have exactly that same expression back. And then use the previous method that you learned here, factorize it, and then hopefully you will see that a factor appears here or there or in both of them. You pull them out. This will cancel the factor that you had already here, and then you will have your factorized form in the set of integers. Yes. So let me give you one more example here. But before doing one more example, let me solve this one with 2 methods, or might be 3 methods. I haven't checked that one. Okay, let us check. The second method is also a systematic method. So method 2, it is up to you which one is easier for you for using in future. So in method 2, so let me write here. So I have 2x squared and then 7x plus 3. Okay, so be careful about this method. Here you multiply this number. So let me write it in this form. So you ask yourself, I need 2 numbers whose sum is equal to 7, this number here, and its product is 2 times 3, which is 6. Yes, this is different. By the way, you see that 2x is not, we cannot give the role of the common term to 2x because 2x squared is not a complete square. So what I'm trying to say, I'm just giving you a recipe to be able to do that. So let us learn this recipe. The recipe tells you that you ask yourself, I need 2 numbers whose sum is this number sitting here containing its sign, and whose product is the product of the first and the last number, which becomes 6. Can you guess those 2 numbers? It's not hard. Guess those 2 numbers whose product is 6 and sum is 7. It's clear. One of them is 1, the other one is 6. If I add them, it becomes 7. If I multiply them, it becomes 6. These numbers are the numbers that you need to use them in this way that I am just telling you. You put equality, you write 2x squared as it is. Instead of this 7x, you break 7x into 2 pieces. I will talk about this method of factorizing in great detail in the future lectures. Okay, but let us just do it very simple here. So this 7x can be written as, I can break it into the sum of 2 terms in infinitely many ways. For example, I can write 7x to be 2x plus 5x. I can write 7x to be, I don't know, minus 4x plus 11x. And this list will continue forever. But there is only one of them which will help you to factorize this in the way that I will describe shortly. How? Break 7x into 1x and 6x that you got from here. So these numbers that you got from here, you would, instead of 7x, you write 1x and then you write 6x. This becomes exactly 7x. Even though I can write the 7x as the sum of infinitely many pairs, the only pair that will work is this pair, x plus 6x, and then you will write 3 at the end. Okay, but then how we should act? you need to take this one with that one or that one. Let us check. For example, let me take this one with this one. You see why. And you will take these two together. You take the common factor between these two terms out, so it becomes x. And then this becomes 2x, and this becomes 1. And you take 3 out from here, it becomes 2x plus 1. Then you immediately see that 2x plus 1 appears here as a common factor. So I can pull it out as the common factor itself. So it becomes x plus 3. And this answer that you get from here is exactly that final answer that we got there. Okay? So that's also one method. So you ask yourself, I need two numbers whose sum is 7, and the product is the product of these two numbers. As soon as you got those numbers, you break the middle term into this number multiplied by x plus this number multiplied by x, and then pairwise factor them out so that you see a common factor. If the first one doesn't work, be sure the next one will work. So you might need to do some trial and error here, but by experience, it's immediate. And then when you factor, definitely you will get a common factor out, and then you can take that common factor out. When I take this common factor out, if you remember from the previous lecture, what is left from here is x, what is left from here is plus 3, so that is my factorization. I don't know, I cannot call this a method 3, so might be this is also possible if you are good with numbers, might be you are able to take 2 out from the beginning and work with fractions, yes? For example, let me call this one method 3. So here I can factor this out. I want to factorize this expression. I factor 2 out, this becomes x squared plus 7 over 2x plus 3 over 2. Okay, but can I do it quickly and I say that, okay, this is the common term, so it means that I put the two common terms here, but then I need to ask myself, can I guess two numbers whose sum is 7 over 2 and its product is 3 over 2? Yes. I don't know, is that clear? What are those numbers? We need two numbers whose sum is 7 over 2, yes, and the product is 3 over 2. Yes. So I think, for example, if you can guess, of course, that's not that hard. Then you can, of course, solve it in this method. But can you guess two numbers whose sum is 7 over 2 and its product is 3 over 2? So I think those numbers are 1 over 2 and 6 over 2. Yes, these numbers. Sorry. Yes, these numbers actually. So it is. Why? Because if I add them, 1 over 2 plus 6 over 2 becomes 7 over 2. And if I multiply them, the multiplication becomes 6 over 4, but 6 over 4 is 3 over 2. But another name for 6 over 2 is actually 3. So the numbers that I am working is 1 over 2 here and 3 here. Okay? But I'm just telling you that this is not something that we count on, because if the fractions are harder, it's very, very hard to guess those numbers, yes? And then you see that I can multiply these two inside, because by default, I want to factorize on the z set, the set of integers, but 1 over 2 is not an integer. But if I multiply 2 here, it becomes 2x plus 1. So this will be 2x plus 1, and then I have x plus 3. So I would not, of course, this is also completely correct, but I would prefer one of these method 1 and method 2, because this is highly improbable if the numbers are very hard to be able to guess those, if the numbers are very big or complicated. Okay. Okay, let me give you one more example of this type, and then I want to solve it again with two methods. Okay, so okay, so number 2, we want to factorize 6x squared plus x minus 15. Okay, again, That's the same story, yes? I have a trinomial, but the first term is not a complete square because of this 6. But I want to make it a complete square. So let me write method 1. So do you remember what was method 1? Yes? I have to make this complete square. What I need is a factor of 6. So I multiply everything by 6. So it becomes 36x squared plus 6x minus 6 times 15 is 90. But to compensate for this multiplication, I have to multiply by 1 over 6 as well. So then 1 over 6 multiplied by this is exactly the same expression. But why this is good, I can write it as 1 over 6. And then I know that I want to give the role of the common term to 6x. So let me write it in a way that you can see it in front of your eyes. Instead of 36x squared, I write 6x to the 2. But this is already the common term itself. So what should I write? I should consider it as 6x as the common term. So what is the factor here is just 1. Yes, 1 times 6x is just 6x. And then I have minus 90. Okay, now if I can solve the problem using this 1 over 6, I just copy and paste it here. Then I open 2 pairs of brackets. I put 6x here, another 6x here. Then I ask myself, can I find 2 numbers whose sum is equal to 1 and the product is negative 90? So the sum is positive 1, the product is negative 90. So the most famous numbers that was the product is 90 is 10 and 9, and 10 and 9 are actually good because they differ just by 1. Yes. So can I adjust the sign? So I put 10 in one of them, and I put 9 in the other one. But the product is negative, so one of them has to be negative, and the sum is positive, so the bigger one is positive. So the bigger one is positive. Yes. This is already in factorized form, but this is not in the set of integers. So, but this is not an obstacle. Why? Because you immediately see that the factorization is not complete, by the way. Here, I can factor a 2 out. It becomes 3x plus 5. And here, I can factor a 3 out. It becomes 2x minus 3. Yes? And then 3 times 2 is 6 times 1 over 6 is totally gone. So this one and this one and that one are gone. So what is left is 3x plus 5, 2x minus 3. Yes? Good. So this is method 1. Let me just solve it using method 2. Yes? Okay, method 2. So if you remember what I said, let me rewrite it here again. 6x squared, then I have plus x minus 15. Okay, here, the s and p that I asked myself here are different here. Okay, what are they? S is this number here, which is positive 1, and p is the product of these two numbers, which is minus 19 again. But you need to ask again the same story. Can I guess 2 numbers whose sum is positive 1 and whose product is negative 90? The answers are correct. Yes, one of them is exactly as before, positive 10 and negative 9. But the interpretation of these numbers are different now. Yes, what should I do? I need to break the middle term into the sum of 2 terms, but I can do it in principle in infinitely many ways, but only one of them will work if my goal is to factorize this. And that one is given by this pair of numbers. Okay, how? So I would write 6x squared. Instead of x, I would write, for example, I don't know, I would write 10x minus 9x. Yes? So these numbers, I will use them to break this into two pieces in the form of 10x minus 9x. This is another name for the same positive x, yes? And then I have negative 15. Okay? So then it might happen, then you need to factor pairwise. For example, I can take what out from here? I can take 2x from here. What is left is 3x, and what is left here is 5. Yes? And between these two terms, I factor minus 3 out. And then here is 3x, and here is positive 5. And you see that was a good factorization, yes? Might be, I don't know, you write minus 9x first and then 10x here, and when you do it, it doesn't work, so it means that you have done it in the wrong order. You change them and then it will work. Okay, so then you see that this common factor can be pulled out. So I will have 2x minus 3. Okay. Okay, you can also work this one yourself if you want. You can factor 6x out and then try to see, can you guess those numbers whose sum is 1 over 6 and the product is minus 15 over 6. But then, of course, you need to work with fractions. I'm not saying it's impossible, but might be it is a little bit harder. Okay, so I hope that you learned what is going on. Okay, but if you have noticed, all the methods that I described here somehow relies on your ability to guess two numbers with the given product and with the given sum. But of course, if the numbers are quite big, it's not possible to do it just by guess, okay? So for example, what happens if I give you something like this? So what happens, for example, if I ask you to factorize this, and even if you have calculator. So for example, 21x squared, and then I have minus 122x, and then I have 165. Yes? If you want to solve this using these methods that I described, for example, this method, you need to ask yourself, can I find two numbers whose sum is negative 122 and the product is 21 times 165? Finding those numbers is probably more or less impossible to guess. Yes? So what can I do here now? So this means that I really need to know a systematic way of doing this. And here I want to teach you that one now, and then we go back and try to solve these problems. Okay. So I would write it as systematic way to factor this expression, ax squared plus bx plus c. Okay, so what you do is this. First, I want to recall you about the quadratic formula for solving a quadratic equation, and that is the famous ABC formula. Yes, so you know that. So you see, I don't have any equation. I have just an expression. There are no two sides. There is only one expression, and that is x squared plus bx plus c. I'm supposed to factorize that, but the recipe that I want to cook up right now needs to solve the equation yourself. So I would say that we solve ax squared plus bx plus c. There is no equal to 0 in the question. I myself put equal to 0 and try to find the solutions. So let me just tell you, do you remember how can we solve the problem? there is a famous formula, ABC formula, that will give me the roots of this equation. Yes. What are they? So x is equal to, let me write the formulas. So let me remind you in this way. We have delta. Delta has one formula, b squared minus 4ac. B squared minus 4ac. This delta is a number. It might be negative, positive, or 0. So if delta becomes positive, then I will have two roots. One root x1 is minus b plus square root of delta divided by 2 times a. The other root, that I will call it x2, is minus b minus square root of delta divided by 2a. So if delta is positive, then I will have these two roots. Both of them are from the set of real numbers. And then, of course, you know that if delta is 0, when delta is 0, square root of delta is also 0. So it doesn't matter if I write minus b plus 0 or minus b plus minus 0. They are all the same. So this means that both roots, x1 and x2, are actually indeed equal to the same number, minus b over 2a. Yes, and then finally, if delta is negative, I will have two complex roots, because square root of delta is a negative number, then I will have a complex number. But this is not the lesson that we want to continue, not our concern here. Because, of course, if this is happening, the formula that I will tell you for factorizing this polynomial will work, but it will work in the set of complex numbers, okay? We will come to that later when, hopefully, we were talking about complex numbers in this set of lectures. Okay. Okay, so we have two scenarios. So delta positive, delta negative. So let me tell you one more thing here. So what happens here in this case, for example, let me add these two roots together to get a formula for the sum of the roots. So if I add these two roots together, so x1 plus x2 becomes minus b plus square root of delta divided by 2a plus minus b minus square root of delta divided by 2a. Yes, I have the common denominator, so the common denominator is 2a. Then I have this added to that one. Positive square root of delta, negative square root of delta will cancel out. Minus b becomes minus 2b, and then this 2 can be cancelled, so now I will get minus b over a. Yes, by the way, this formula is also valid if I have this situation. Yes, because if I have this situation, x1 and x2 are the same. So when I add them, it becomes 2 times of this number, which becomes minus 2b over 2a again. So this formula is also valid if I have this situation. Okay, this is, by the way, this is also a very important formula. We will come to this application of these formulas later, hopefully. But then let me calculate the product here as well. Okay, so let me multiply x1 by x2. So what happens if I multiply x1 and x2 together? So then it becomes minus b plus square root of delta divided by 2a multiplied by minus b minus square root of delta divided by 2a. Yes? So then the denominators multiplied together becomes 4a squared. But then hopefully you can immediately realize that that's the conjugate pattern. I have two terms added, the same two terms subtracted, and I am interested in multiplying them. So conjugate pattern tells me that this becomes the first one to the 2, minus b to the 2, minus the second one, square root of delta to the 2. But if I simplify this a little bit further, this becomes b squared. This power of 2 will actually cancel this square root. It becomes negative delta, and then I will have 4a squared. But delta is just a symbol, a shorthand notation for this combination of numbers, b squared minus 4ac. So if I plug it back there, it becomes b squared minus b squared minus 4ac. and then divided by 4a squared. Okay, instead of delta, I just simply put this one because I had a negative sign behind. I respected to put a pair of brackets. And then I multiply this, it becomes b squared minus b squared. The next one becomes positive 4ac, yes? Minus b squared, positive 4ac, divided 4a squared. And then this one and that one are canceled. Then I have 4ac divided by 4a squared. And then I can simplify 4 and 4, one of these a's. So then it becomes c over a. Yes? So what I got is this. I got that x1 plus x2 is minus b over a, and I got x1 times x2 is c over a. By the way, this formula I told you, this is also valid for this case, because if x1 and x2 are the same, so when I add them, it becomes 2 times of this number, which is again minus b over a. But this is also valid. Let us see why. If this happens, if I have x1 times x2, if both of them are equal and equal to this expression, if I multiply them, okay, so I just wanted to tell you that if this is the case, this formula that I found here is still valid if I have this situation. In this situation, because x1 and x2 are both the same and equal to minus b over 2a, so I multiply them, it becomes minus b over 2a, then it becomes b squared divided by 4a squared. But here, this formula is valid under this condition. It means delta is 0. When delta is 0, it means b squared is 4ac. So instead of b squared, I can put 4ac, and then 4a squared, this becomes again c over a. So these formulas that I got here are valid for this, for that, and even further for this one. But this is not our concern yet, so I don't want to distract it from you. So these are two very important formulas regarding the quadratic equation. The sum of the roots is negative b times divided by a, and the product of the roots is always c divided by a. Yes, but you might say that, okay, why this is useful? Let us see. So I don't need this one now, so let me clean this. Okay, so here, number 2, ax squared plus bx plus c can be factorized in this form. A, this is just a, and then I put two pairs of brackets with x inside, and then I will have minus x1, which is one of the roots, and minus x2, which is the other root. And this is the factorization of that expression. You see, so I cooked a recipe here. I want to prove why this is correct for the time being, but let me explain what is the recipe. If I give you this expression and I ask you to factorize that, be careful. There is only an expression, not an equation. But the recipe is the first step, you yourself put it equal to 0 and solve it. And find the roots x1 and x2. By the way, there is no guess involved here. You have a quadratic formula. You can use the formula and at most your calculator to punch some numbers inside the calculator according to the quadratic formula and find the roots x1 and x2. So what you need to remember is that then this formula gives you the factorization of that quadratic polynomial. Okay? The only thing that is left for me to do is to convince you that this is indeed the case. And the reason is based on this argument. Let us check. So I want to prove this for you now, why this is correct. So I start from the left-hand side. The left-hand side is ax squared plus bx plus c. I can pull a out. What is left? This becomes x squared. This becomes b over ax, and then the next one becomes c over a. Yes? Why this is correct? Because if I multiply this back, I will get again the same expression. But look, c over a is x1 times x2. And b over a is negative of x1 plus x2, because x1 plus x2 is negative b over a, so b over a itself is minus x1 plus x2. So what happens here? This becomes equal to a, and then I put x squared. Instead of b over a, I put minus x1 plus x2 times x, and then I will have x1, x2, yes, instead of c over a. And then you can immediately realize that this is a times x minus x1 times x minus x2, using that common term identity, yes? The common term to the two, the sum of these two numbers, minus x1 minus x2, becomes minus x1 plus x2 times the common term. Multiplication of these two, which becomes positive x1, x2. And this means that this expression, this quadratic expression, is indeed in this form, and this is already a product form. So that's the factorization of my polynomial. Yes? Okay. So let me keep this recipe here and then try to solve some examples here for you. So I think it would be good if I solve the previous example here now. So example, so factorize. So this example, we already did it with the previous methods. So let us just do it with this new method. Okay, using the recipe. That's the recipe that I actually cooked up here. Okay, so what should I do? You see, this is not an equation. I myself, I want to follow the recipe. The first part of this recipe is to put that equal to 0 and solve it. Okay, so let me just do that. I put 6x squared plus x minus 15 equal to 0. Okay, so if you want, you can calculate delta first. So let me calculate delta. Delta is b squared minus 4ac. But b is 1, so 1 to the 2 minus 4 times a times c, which is minus 15. Now what happens here? This becomes 1, and then this becomes positive 360, yes? So this becomes 361, okay? And that's positive. So it means that I have two roots. So what are the roots? X is equal to minus b plus and minus square root of delta divided by 2a. So minus b is minus 1 plus and minus square root of delta, which is 361, divided by 2 times a, it becomes 12. So you see, there is nothing that I am guessing. I'm just following the formulas. If that number is hard for you, no problem. You can take your calculator and punch this number in the calculator. You will get 19. Square root of 361 is 19. So you see, there is no guessing. It's minus 1 plus and minus 19 divided by 12. Then I will get two roots, yes? Minus 1 plus 19 divided by 12, which becomes 18 over 12. If I simplify by 6, it becomes 3 over 2. So it means that x1 is 3 over 2. This is one root, no guessing. And then I have minus 1 minus 19 divided by 12. It's minus 20 divided by 12. I divide by 4, it becomes minus 5 over 3. So the next root is minus 5 over 3. No guessing. It's of course longer, but you don't need to guess anything. So that's the price, yes? And when you found a number, you immediately use the second formula. So what you do is to write 6x squared plus x minus 15 is equal to a, which is the coefficient of x squared. In this problem, that's 6, and then you write two x's here and there, and then you write minus x1 minus x2, and it doesn't matter, by the way, which one is x1 and which one is x2. So it becomes minus 3 over 2, which is my x1 there, and minus 5 over 3. And of course, because I told you that by default we factorize on the set of integers, fractions are not allowed. Yes, we need to get rid of those fractions, and that's not hard. You see, this 6 can be written as 2 times 3. And then I have 1, 2, 3, and 4 numbers. I want to multiply them together. So I will multiply. Of course, I can multiply 3 here, but 3 doesn't make, this is not a good thing because it becomes 3x minus 9 over 2. It's still fraction is left. But if I decide to multiply 2 here and 3 there, I will get rid of both fractions simultaneously. So 2 will go in, so it becomes 2x minus 3. And then 3 will be multiplied inside the second bracket. It will give me 3x. 3 and that 3 will cancel. Minus 5 becomes positive 5. And if you go back and check, hopefully you see that this is the answer that we got there by those two different methods. Okay. So what is, of course, those methods, I would say that they are easier, but of course they rely on your ability to guess. If you guess, the reward you get back is just calculating it, solving it in a shorter way. But now you need to pay a price. You don't need to guess at all, but of course it is a little bit more lengthy. But sometimes, as I gave you that very hard example, it's inevitable, yes? So let me give one of those examples that probably everyone, this example that is still on the board. Let us solve that problem using this method. So if you don't mind, let me clean this one here. Keep the recipe on the board yet. So this, I start solving this because I have already used my calculator to calculate those hard numbers that will pop out here. So here, what I need to do, we solve ax squared plus bx equal to 0 plus c equal to 0 first. So this is, I want to factorize. So let me call this one number 1. Okay, this one number 2. I want to factorize this. So I use the formula. Let me calculate delta first. Delta is b squared minus 4ac. It's minus 122 to the power of 2 minus 4 times 21 times 165. I have calculated this using my calculator. The first number is, this number is 14,884. And then minus this becomes 13,860. You see, I am not guessing at all. I've used my calculator to calculate. And if you calculate this one, it becomes 1024, which is positive. And I will have two roots. So let me write them here. So x is minus b plus and minus the square root of delta divided by 2a. So minus b is 122 plus and minus a square root of 1024 divided by 2 times a, which is 42. Yes? And then again, you put this number in your calculator, square root of 1024 becomes 32. So it becomes plus and minus 32 divided by 42. Yes? Then I will get two answers here. So it becomes 122 plus 32 divided by 42. So it becomes 154 divided by 42. So if I divide by 2, it becomes 77, 21, and I divide by 7, 11 over 3. Let me double check. I divided by 2, 77, yes, and then I divide by 7, that's right. Then the next number is 122 minus 32 divided by 42. So what is this one? It becomes 90 over 42. So if I divide by 6, this becomes 7, and this becomes 15. So it means that, okay, my numbers x1 is 11 over 3 and x2 is 15 over 7. Okay, now I can use the formula here. So what I had here, do you remember? 21x squared minus 122x plus 165 is equal to. According to this formula, I have to put a, which is 21 in this problem, and then I have x here and x here. X minus x1, I call this one x1, it doesn't matter. So I would write minus 11 over 3, and then I will have x minus x2, which is 15 over 7. Of course, this is factorized, but this is factorized in the domain of rational numbers because the fractions are involved. Yes, I want to do it if possible on the set of integers, and then it's easy to see that this 21 can be written as the product of 7 times 3, and I will take this 7, multiply it here to get rid of that 7 in the bottom, and then this one I multiply it here to get rid of that 3 in the denominator. So then you see that I will get 3x minus 11, and then I will have 7x minus 15. Yes. So you see that it was probably not possible or not that easy, at least, to do it by guess. But this will give you the solution for the factorization of these polynomials ax squared plus bx plus c in full detail. Yes. Okay, let me solve one more interesting problem using this one, and then we can stop here, okay? And then I will continue to the next methods later, okay? So one thing that I want to solve here is this interesting problem. Yes, it's a little bit harder, so you need to be a little bit experienced to be able to solve this. Okay, so let me write an example like this. So I want you to factorize this expression. So example, so factorize. So this is x squared plus 3xy plus 2y squared, and then I have minus 2x minus 5y, and then I have minus 3. Okay. So these kinds of expressions will appear in your future studies when you are probably studying about conic sections, yes, geometrical objects that are produced when a plane cuts a cone, yes. Okay, but sometimes you need to be able to factorize this expression to be able to determine what type of conic section is represented by this equation. I don't want to distract you about those things. What we concern here is that we want to factorize a polynomial like that. Yes. You might think that factorizing this and this lesson are not related, but let me tell you how to relate and connect these two problems. So I will present the solution here. You need to understand what is going on. Then I will, as usual, put some examples and questions below the video, and then you are supposed to work on them, okay? And then next week I will have the solution for them. So by this method, you will increase your skills about factorizing these kind of polynomials. So far you need to have this. So you just follow me and try to understand the steps, okay? Don't be bothered, how could I guess this one, okay? You need to see one of them and then put this in your toolbox and then try to use the same ideas if you confront some new problems, yes? That's the whole point of mathematics. We'll learn some, we have some experience, and then we hopefully will be able to solve a problem which is not already solved, yes, using the methods and tricks that we have gathered with us through our journey and expedition of learning mathematics. Okay, so what I do here, I want to see this as a quadratic polynomial in 3 terms, okay? And I want to express it with x squared because at least x squared is a complete square. So I would write it like this. I would write x squared, but between this one and that one, I want to write it as a quadratic polynomial in terms of x. What does it mean? It means that I should have a term involving x squared and only one single term involving x. But here I have 2 terms involving x. So what does it mean? It means that I can factor x out. So this is a very strange way of factorizing, but you need to wait and see why it works. So I pull x out from here. My goal is to write this in the form of a quadratic polynomial in terms of x. And then what is left for me is these 3 numbers, these 3 terms. So I put them, so for example, in a pair of brackets at the end. Yes? So if you see, you can imagine in your head that is B, you can imagine that this is your C, and you can imagine that this number 1 is your A. Yes? So let me write it clean here. X squared, 3y minus 2x, and then I have 2y squared minus 5y minus 3. And you want to factorize this. In principle, this recipe should work, yes? Because this recipe tells you that what you need to do is find the roots. But here, in these examples, our roots were numbers, but here our roots become expressions, algebraic expressions on their own. Why? Because in these cases, our coefficients were just numbers, but here if I ask you what is the coefficient of x, it's not a number, it's an expression, 3y minus 2. And if I ask you what is this, that's not a number, that's a polynomial. Okay, but it doesn't matter. So it means that if I want to do this, I put delta, I calculate delta first. Delta is b squared, so let me write it with capital letters here. I use capital letters. So b squared minus 4ac. So b squared is 3y minus 2 to the 2. Yes, and 4 minus 4 times a, which is 1, and then times c, which is 2y squared minus 5y minus 3. Yes? I have to simplify this as I am actually did with numbers, as I did with numbers, yes? But here, I want to raise it to power 2, so I have to use quadratic rule. So the first one to the 2 is 9y squared. 2 times the first one times the second one is 12y, and then I have 4. And then I have minus 4 here, I have to multiply it there. So it becomes minus 8y squared, positive 20y, and then I have positive 12. Let us simplify that. So this means that 9y squared, 8 squared is y squared, and then minus 12y, and this one is positive 8y, and then 4 and 12 becomes what? 16. Yes? But I hope that every one of you immediately can guess what is the factorization of that. It's a quadratic pattern, yes? So this becomes that. So this means that delta is y plus 4 to the 2. Yes? The first one to the 2. 2 times the first one times the second one, and the second one to the 2. Okay, now I need to go and calculate the roots. The roots means x in terms of y, yes? You shouldn't expect to get numbers because your coefficients are not numbers. So if you don't mind, let me write it here. So I would write the equation, x is equal to minus capital B plus and minus square root of delta divided by 2a, yes? But what is minus b? B is this expression. This is b. And I multiply b by a negative sign. So the first one becomes negative, the second one becomes positive. So this becomes minus 3y plus 2. And then I have to write plus or minus square root of your delta. Your delta is y plus 4 to the 2. And then this becomes divided by 2 times a. but a is just simply 1, so that's 2. But then you have a square root of y plus 4 to the 2. In principle, it becomes the absolute value of y plus 4, but the absolute value of y plus 4 is either positive or negative, so it doesn't matter. So I can just write it as minus 3y plus 2 plus or minus y plus 4 divided by 2. Then I need to consider two cases, one with positive sign, the other with negative sign. So I would write like this. One with positive is minus 3y plus 2. I choose the positive sign here, so it becomes plus y plus 4. And then I divide it by 2. But what happens here? Minus 3y plus y is negative 2y. And then 2 plus 4 is 6. And I have divided by 2. So I factor a 2 out. It becomes minus y plus 3 divided by 2. Then this 2 and that 2 are gone. So what I get is x1. x1 is minus 1 plus 3. Yes? And then the other one with the negative sign. So it becomes minus 3y plus 2. And then this negative sign is for the first one and the second one. So it becomes minus y minus 4. And then again divided by 2. So what happens? Minus 3y minus y is minus 4y. 2 minus 4 is minus 2, and then I have divided by 2. I can factor negative 2 out, for example. It becomes positive 2y plus 1, and I have divided by 2. When I simplify those 2's, it becomes negative times 1, negative times this expression. So it becomes negative 2y, negative 1. So this means that x2 is this expression. Okay? So, and then if you don't mind, let me write that last piece here. Okay. So the expression that I want, so let me write it here. This expression is equal to a, which is 1, so I don't write it. And then I have x here, x there, and then minus x1, so it becomes minus y plus 3, and then minus 2y minus 1. But we can simplify that. So it becomes x plus y minus 3, and then it becomes x plus 2y plus 1. So that is the factorization of that polynomial. Yes? Okay. I hope that the video was somehow useful for you. If you like the video, I really appreciate that if you can give me a thumb up, because probably it will help, it will cause that the YouTube will propose the video to more people. And then I will upload questions related to the material that I covered here below this video. And then hopefully, if you want to improve your skills, you will start working on those problems. And the next week, I will upload another video with complete solutions to those problems as usual. Okay. Until the next video, thank you and goodbye.